So I'm going to do a review. I'm just going to go over the review for the Vertex Edge graph problem that was posted. So what you see here is you have obviously a park, and you have the apple orchard, you've got Birch Grove, Cottonwood Pond, Deer Run, Eagle Lookout, and of course Fish Lake. So these are A through F parts that you can stop. Uh, they all paths between them. Something to note is that you see from here to here, you've got one path that goes from Apple Orchard to Birch Grove. However, you have two paths that go from Birch Grove to Cottonwood Pond. Just in the same way, from Deer Run to Eagle Lookout, you have three different ones. And so when we write our first matrix, it's about noting the different number of paths from each place. And so I said my from group is on the column on this side over here, and the to group is the ones on the top you can see here. So obviously nothing has a path to itself, so you don't have anything like we saw in the example in class where we had the fish or had a loop around it. So obviously you can have zeros where you have AA, BB, CC, DD, EE, and FF. However, most of these things have just one path, uh, but you've got the B to C and then the D to E that have a number of them. So we're going to have to go through this, and you can see this here. From A to B, obviously we're looking from A to B. There's only one path to go from A to B. From A to C, no paths. In fact, the only paths A can get to, if I'm standing at the apple orchard, I can only walk to Birch Grove and to Fish Lake in one step. Since this is the first matrix, it's going to be measuring how many paths one step away can we get to. And so, so you can walk around and look at the different paths, number of paths that you can get to. So for example, from B to C, there are obviously two different paths. So from when I look at B to C, there are two different paths. We can go backwards as well, from C to B. So we go down to the C row, from C to B, there are also two different paths. So going one direction is obviously would be different. If I'm starting at Birch Grove or if I'm starting at the Cottonwood Pond, then I have to address those individually. And you can see here, you can pause the video if you want to, just to double check your answers. And you can see the different values that I've put in to this matrix that represent the different values. You can see here, from D to E, we have three paths. So you can see the three show up when I'm going from D to E as a 3 right here. And then E to D, we also have the three paths. And the majority of these are just zeros or ones. So you got to make sure you get the right one as you look at the picture. So it's pretty straightforward to get that correct. And that's pretty obvious. That shouldn't have been too difficult to master. But then I ask you to square it, and what that does, it will map out the different two-step paths that you can find. And so this one is a little bit more complicated. Of course, you don't have to figure it out. You just go into your matrix in your calculator, you square the original one, and then copy down the correct values here. So unless you messed up typing it in, you should get this exact matrix. Now, the point here is not really to get the matrix. The point is to explore what it's saying. The question was to find two-step paths between entry 3, 3. That's one thing. And the second part is to find it from 5 to 3, right? The entry 5, 3. So if we look at that, that's the paths. 3, 3 would be from C back to C, because if I go to 3, 3, that's the third row, third column, right? It's a 5. So there's 5 different paths to go from C and then back to C in 2 steps. And I'll explain that in just a minute. 5, 3, so we go to the 5th row, and we go all the way over to the third column, which would be C. So there's 3 different paths to get from E to C, or from C to E, either one. And to explain that, I wrote out the matrix for this one, and so we're exploring the number 5 here because it's going from C back to C in 2 steps. Right, so if we go back up to our picture, what I did was I simply redrew this part and only this part. So we're going to go from C So I wrote down every adjacent step to C. So I wrote down Birch Grove and Deer Run in kind of a shortened image. And you can see that kind of adjusted here. So from C, I can go to B in either two directions, the first one or around the second one. I can go from C to D. There's only one, so I didn't really bother labeling that. But to write them down, what you have to be careful about is taking different paths, going clockwise or counterclockwise, all makes a difference. And you can read the explanation on the side. I just wanted to walk you through it. From D, or sorry, if I start at C and I go to D and then back to C, that's 2 steps, so 1, 2. The only requirements is that I have to take 2 paths, and sometimes that means retracing the same path because I'm going in a different direction, so it means it's a different path. C to D, there's only one way to do it. But to go from C to B, I could go from C to B using the first path and then back. And of course, I can do the same thing with the second path. I can go from C, go down to B, and then back on that path. But then I have 2 options. What if I went around in a circle, went from 1 to 2 or 2 to 1? And so these are the 2 different ones where I'm going in a clockwise fashion when I go 1 to 2, or counterclockwise when I go from 2 to 1. So you can see those different things listed here. I wrote them out separately, so that, and I labeled them as 1 and 2 so that I could make sure to keep it organized. That way it's a lot easier for someone grading my paper to understand what I'm trying to say. Okay, you can pause the video, read that if you need to, or rewatch that part. The next question is actually a little bit easier. Going from C to E in 2 steps. Well, I can only really take the most obvious paths. From C to D is 1 step, and then D to E is another step. But there's 3 ways to get from D to E, and obviously E1, E2, and E3, what I've got listed here, are those specific ways. Really simple to do. And so you go from C to D and then take E1, then C to D and take E2, C to D and take E3. So if I look at that 5-3 entry, all right, so 5 is the E and 3 is C, it tells me there's 3 different answers to this question. And so clearly I can see I found 3 ways when I wrote it out like this when I look at the picture. And that's one way that we can use a vertex edge graph and apply it to kind of a real life scenario when you're looking to find shortest paths or longest paths and different routes. Make sure that you understand how to do this problem. The one on the test is similar to this. It's actually not quite as involved as this, but if you can do this one, it should be pretty easy.